Hello friends, welcome to my channel Civil Methods. In this video, we will learn Pascal's law. According to the Pascal's law, the pressure at a point in static fluid is equal in all directions, or pressure transmitted equally in all directions. Now static fluid means the fluid is at rest. It means fluid at rest. Now pressure is equal in all direction. It means P is equal to P in x direction equal to P in y direction and P in z direction. Okay. Now to prove Pascal's law, we consider a small fluid element wedge shaped ABC and dx dimension in x direction and dy in y direction and dz in z direction. Okay, and now the width of the small shaped element wedge shaped element is the width of the small wedge shaped element is unity. Okay, and perpendicular to the plane of the paper. Now the pressure in x direction is px. Okay, and now the pressure in y direction is py, and pressure in z direction is pz, and angle acb is theta. Angle acb is theta. Now we know that pressure is P is defined as force per unit area. So the force is pressure multiplied by area. Now, now force on the face AC is pressure pressure on AC face into area of AC face. Now pressure on AC face is Px and area of AC face is dy into unity, which is 1, so dy multiply by 1, so it is Px dot dy. And taking horizontal force forces in right direction as positive, and taking vertical forces in upward direction as positive. Thus Px dot dy is in upward direction and it will be positive. Now force on the face AB is equals to pressure of at face AB into area of face AB. Pressure at face AB is Py, and area of face AB is length dx and width unity dx into 1, so Py dot dx. Now force on the face CB in x direction. By using diagram PZ, by using geometry and by alternate angle, this angle will be theta and this angle will be 90 minus theta. And after resolving Pz in horizontal and vertical component, so it will be Pz cos 90 minus theta, and it will be Pz sin 90 minus theta. Okay, so PCB into area of CB, pressure is CB in x direction. Pressure CB in x direction is Pz sin 90 minus theta into area of CB. Length is dz and width is 1. And sin 90 minus theta is cos theta. So Pz cos theta into dz. Now force on the face CB in y direction, and given by PCB in y direction into area of CB, and PCB is Pz cos 90 minus theta into again dz is length and unity is width, so it will be pz sin theta into dz. Now taking vertical forces in upward direction positive, but this force is in downward direction, so it will be negative. And again this force, because the horizontal forces in right direction is positive, but this force is in left direction, so it will be negative. Now again from triangle ACB, if theta, then this will be perpendicular and this will be hypotenuse and this will be base. From triangle ACB, sin theta is equal to perpendicular by hypotenuse is equal to dx divided by dz, or we can write as dz is equal to dx divided by sin theta, and cos theta is equals to base divided by hypotenuse, and base is equal to dy divided by dz, and dz is equals to dy by cos theta. Now for forces, force on face AC, force on face AC is Px. Dy. and force on face AB. For face AB, the force on face AB is Py dot dx. The force on face CB in x direction, because it is negative, so it will be in left direction. So Pz cos theta dot dz, and in y direction, because it is negative, so it will be downward at Pz sin theta dot dz. Now by free body diagram, forces in x direction, it is px dot dy, px dot dy in right direction, and pz dot cos theta dot dz in left direction. And force in vertical direction or y direction is pz sin theta dot dz, and w the weight of the fluid element, and py dot dx. Now for the equilibrium of the element, summation of fx is equals to 0 and summation of fy is equals to 0, because the fluid is in static or fluid is at rest. This is equation 1 and this is equation 2. By equation 1, forces in x direction, px dot dy, and minus, because it is in left direction, pz cos theta dot dz is equals to 0. Now px dot dy is equals to pz cos theta dot dz, and now dz is equals to dy by cos theta. Cos theta to cos theta cancels, dy to dy cancels, and now px is equals to pz by equation 2, forces in vertical direction, py dot dx and pz sin theta dot dz, and w is equals to 0. Because the fluid element is very small, so w will be negligible or is equal to 0. Now py dot dx is equals to pz sin theta dot dz, and dz is equals to dx by sin theta. So py dot dx is equals to pz sin theta into dx by sin theta. Sin theta to sin theta cancels, dx to dx cancels, so py is equals to pz. Now by these two equations we can write px is equals to py is equals to pz. Now according to the Pascal's law, the pressure at a point in a static fluid is equal in all directions. So this is the proof of Pascal.